Good day, guys. This is your Day 9 notes. Today we're going to be reviewing making graphs of cubic roots and cubic functions. This time we're going to be given a description and we have to make the equation to match it. So first thing I want to do is look at example 1. Start with the graph of y equals x to the third power. So let's go ahead and quickly review that graph. Y equals x to the third power. So what I'm going to do is I'm going to pick my 5 values. Remember from last time, 0 is in the middle. 0 to the third power is 0. Pick the point before and after. -1 and +1 to the third power is -1 and +1. And then we pick the numbers before and after those ones, -2 and +2, which give me a -8 and +8. So our graph has an anchor point at the origin, 1 point left and right diagonally, and then 2 squares right and 8 squares up. 1, 2, 3, 4, 5, 6. Be about right here. -2, 1, 2, 3, 4, 5, 6. That'll be about right here. And we get this original graph to begin with. Now we need to work on making a translation. It wants to translate it 2 units to the left and 1 unit down, and then write the equation. So what we're going to do first is quickly review how we can manipulate this equation. Now, what I'm going to do is I'm going to write down a couple of things that we can do to this basic equation. First of all, the a number. If it's negative, then it's going to flip your graph. We didn't have any mention of anything flipping over the x-axis, so it's not going to be, we're not going to have a negative number in front. Also, if you have a fraction or a whole number, then the effect is that it can either compress, or squash in other words, or it could stretch your graph. None of those descriptions were mentioned in our example, so I'm going to go ahead and leave the a out. When you're adding or subtracting a b, this has the effect of moving it either left or right. And then when you add a number at the end, plus or minus a c value, this has the effect of going either up or down. So let's go ahead and look at what we have here. It says start with the graph of y equals x to the third power. Translate it to 2 units to the left and 1 unit down. So y equals, I have no mention of flipping or compressing or stretching, so I have no a value. I'll go parentheses x. I want to go 2 units to the left. Now left may seem like it's going to the negative direction, but actually it's going to be written as a +2. It's the opposite. We still have it to the third power, and now we're going to go 1 unit down. That means -1. So what I want to do first now is make a table for these new points. X plus 2 to the third power -1. I'll go ahead and switch my color up. I'll make a table over here. X plus 2 to the third power -1. And I'll give my y values. Alright, so the effect I have described says that the anchor point should translate 2 units to the left, 1, 2, and 1 unit down. So I should have a graph right there. The x value for that is at -2. So I'll make that right here. -2 plus 2 is 0. Sorry about that. I have -2 plus 2, which is 0, to the third power is still 0. -1 is -1. -2, -1, there's my anchor point. I'm going to pick the points that come before and after. And so -3 plus 2 is -1, to the third power is -1. -1 is 0. So -3, 0, I have a point. Actually, I think it's supposed to be at -3, -2. There we go. Did my math wrong there. The reason is -3 plus 2 is -1. -1 to the third power is -1. -1 minus 1 more is -2. So it should be down here. There we go. My point back up. That's the mistake I made earlier. And then when I plug in a -1, -1 plus 2 is +1. To the third power is still +1. -1 is 0. So I have a point right here. And then if I pick the points come after that, I have a 0 there. 0 plus 2 is 2. To the third power is 8. -1 is 7. So that's 0, 7. 1, 2, 3, 4, 5, 6, 7. And then I have another ones down here. So I get these points like that. So my graph, actually, here it goes. My graph has moved 2 units to the left and 1 unit down. Just a translation. Now let's go ahead and look at our second graph. This is the cube root. The cube root function also behaves like an S, but the S kind of goes from left to right, increasing. So we have this point, and this point. And then we have at 8, we go down 2, 10, 9, 8. And then at positive 8, we go up 2. So we had this graph that we revisited from last week. The values for this, x, and the cube root of x are as follows. I can get all my points here. 1, 2, 3, 4, 5. 0, 0, negative 1, negative 1, positive 1, positive 1, positive 2, positive 8, negative 2, negative 8. Now, just like our other equation, we can do a couple of things to this too. If we multiply times the number a, if it's negative, it flips over the x-axis. If it's a fraction, it compresses. If it's a whole number, it stretches. Then we can take our cube root of x in parentheses. We can either add or subtract a number to make it go left or right. And then we can either add or subtract a number on the outside to make it go up or down. That's our C number. This is a B in here. So let's see what it wants us to do. Stretch it out by a factor of 2. That's going to be an A number thing. That's going to be an A in the front. Shift it 1 unit to the right. That's going to be a B number thing in parentheses. And then 2 units up. That's a C number thing. That's going to be an up-down movement. So my equation should be y equals stretching factor of 2 times the cube root of parentheses x. There's a delay on this computer. X. I want to go to the right one. That means it's going to be minus 1. All of that's under the radical symbol. And then with a plus 2 on the outside. So let's go ahead and make this graph now. I'll go ahead and get a mini table set up. X here. Here's my y value. My equation is 2 times the cube root of x with the minus 1 plus 2 to get that up and down, to get that upward movement. Let's pick my 5 values. The middle one should be whatever makes the radical 0. So to go one number minus 1 would give me a 0. Well, that would be a positive 1. So I have 1 minus 1, which is 0. 0 to the third root is still 0. Times 2 is still 0. Plus 2 is 2. The numbers that come before and after. So now I have 0 minus 1 is negative 1. The cube root of negative 1 is negative 1. Times 2 is negative 2. Plus 2 is 0. Now I'll go ahead and use positive 2. So I have 2 minus 1 is 2. Excuse me, 2 minus 1 is 1. The cube root of 1 is 1. 1 times 2 is 2. 2 plus 2 is 4. Now I want to make an 8 in the parentheses. What number minus 1 will give me 8? That would be 9. Because 9 minus 1 is 8. The cube root of 8 is 2. 2 times 2 is 4. 4 plus 2 is 6. Right. And then I'll pick the number before it. But I want to get a negative 8 on the bottom, so I'll have to use a negative 7 down here. Negative 7 minus 1 is negative 8. The cube root of negative 8 is negative 2. Times 2 is negative 4. Plus 2 is negative 2. So my points are at negative 7, negative 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. So here's 1 point. 0, 0. Right there. 1, 2. 1, 1, 2. 2, 4. 1, 2, 1, 2, 3, 4. You see it's already stretching because of that 2 we had in the beginning. And then at 9, 6. 1, 2, 3, 4, 5. So we get this nice stretched out graph that curves up here and then continues on over here. So it's been translated, it's been stretched, it's been shifted 1 unit to the right and 2 units up. That means the anchor point went from here, 1 unit to the right, and then 2 units up. I can show that 1 unit to the right and then 2 units up. There we go. There's our anchor point. There's our translation. So we're going to practice more of this. For this one now, start with the graph of y equals x to the third power. So here's my base function, a x plus or minus some b number to the third power plus or minus some c number. Let's see what kind of translations I want. Reflected across the x-axis, so that means I have to have a negative number. Do they tell me to compress or to shrink? Give it a vertical compression by a factor of 1/2. So to get it to flip, I have to have a negative sign. To get it to compress, they give me the factor of 1/2. So negative 1/2, parentheses, x. Now let's talk about sideways movement. Shift it 2 units to the left. Left means plus 2 to the third power. And then step up and down now. And up 2 units. That would be plus 2. So y equals negative 1/2, parentheses, x plus 2 to the third power plus 2. All right, let's make a quick table for those points now. Here's my equation. I'll go ahead and just make my lines here, try to squeeze them in. For the sake of efficiency, I'm going to go ahead and use my calculator to make the work a little faster. The idea for the cube root is that I always want to know what's going to make the inside of this 0. So I begin with negative 2 to make the inside of the parentheses 0. Then I can go the number before, the number after, the number before that one, and the number after that. These will give you my values. Negative 4 plus 2 is negative 2. To the third power is negative 8. Half of negative 8 is negative 4. Make it opposite, because there's a negative sign here. It gives me positive 4. 4 plus 2 is 6. Let's try that again with negative 3. Negative 3 plus 2 is negative 1. Negative 1 to the third power is still negative 1. Negative 1 cut in half and change its sign becomes positive half. Positive half plus 2 is 2.5. Let's try with negative 2 now. Negative 2 plus 2 is 0. 0 to the third power is 0. 0 times negative 1/2 is still 0. 0 plus 2 is 2. Now we'll go with negative 1. Negative 1 plus 2 is positive 1. 1 to the third power is still 1. Negative half of 1 is negative half. Negative half plus 2 is 1.5. Now we'll use 0. 0 plus 2 is 2. 2 to the third power is 8. 8 cut in half and change its sign becomes negative 4. Negative 4 plus 2 is going to be negative 2, I believe. Let me double check all my values because I feel like I might have rushed something a little bit. So we're going to have negative 0.5, x plus 2 to the third power. And after that we have plus 2. Do a quick table. And it looks like we might be on the right track. Negative 4 should be 6, negative 3, 2.5. Negative 2 is 2, negative 1 is 1.5, and 0 is negative 2. Perfect. So we can now graph this. Negative 4 is 6, negative 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That's up here. Negative 3, 1, 2, 3, 2.5, 1, 2.5. Negative 2, positive 2. Negative 1, 1.5. 0, negative 2. So our graph essentially has been switched directions and then shifted over. All right, not too bad. Now let's work from just a graph. If they don't give us any written description, how can we figure out what our equation will be? So let's look at the graph first. This graph, I know for number 4, is already going to have a parent graph of y equals x to the third power. Now I have to ask myself, is there going to be an a value associated with this? Is there going to be a plus or minus in the inside to move it left or right? And a plus or minus on the outside to make it move up or down, a c value. So let's see what I got. Y equals. The graph goes left to right increasing, so it's positive. And my anchor point is right here. My next anchor point is 1 to the right and 1 to the left diagonally. So nothing there gets shifted, compressed, or anything. I mean, nothing gets compressed or stretched or flipped. So I don't have an a value, in other words. And go right to parentheses now. Erase that random mark. All right. And I have a point right there. Now we have x. I can see that normally the graph crosses at the origin, but it's been shifted over 2 units to the right. That's going to be a -2 inside my parentheses. So from here, it went 2 to the right, and then it went 1 unit up. That's +1. So my equation is y equals x minus 2 to the 3rd power plus 1. That's an x right there. All right, now let's try the next one. Here we have the graph of y equals the cube root of x. Remember, we can rewrite this with a number in front to either make it switch direction or to stretch or compress it. And then I can also, in parentheses inside of it, I could add or subtract another number to make it go left or right. And then outside of the right sign, I can add or subtract another number to make it go up or down. So let's see what I got. Let's find the anchor points. Usually, I start at the origin. But my anchor now seems to be right here in the middle. So it's already shifted to the left. I can see that. But it's also been stretched. Usually my anchor points go 1 up to the right and 1 down. But here I have to go up 1, 2, 3. Well, actually, yeah, 1, 2, 3, down 1, 2, 3 before it hits. So what I have is a vertical stretch of 3. Those anchor points have been stretched quite a bit. Now I have the cube root of x. Since it started at the origin but moved to the left 1 square, it's going to be a +1. And then it also moved up 2 squares, that's going to be a +2. So here's my equation. Y equals 3 times the cube root of x plus 1 plus 2 on the outside. So here's the basic idea. You're going to just basically take your current equations and manipulate them to make the equations either described or shown. Your assignment today, excuse me, that's the wrong assignment. I should do the right one. Where's algebra 2? I don't have it on here. Let me pull it up right now for you guys really quick. I already had it here for you. Downloads right here. Whoops, that's the wrong one still. This will be algebra 2, day 10. Here we go. So here's your example. I don't care about domain and range for any of these graphs. All I care about is the actual equation. You can get that. That is sufficient enough for me. So day 10 is your homework. Get that done, and that's the last topic for this 3 weeks. Best of luck, guys.